Good morning and welcome to a terrific Math Tuesday. Here is our Delta Math for today. We are reviewing factoring numbers and also starting to work with our rational numbers. Yesterday we spent a lot of time with scientific notation, which is another thing that we'll reinforce today with some individual practice, but also factoring integers is a very key skill, and that's going to help us when not only when we're working with integers, but when we're working with rational numbers, particularly fractions. So let's take a look at those skills. Just going to get warmed up here with a bit of division and multiplication. So here, negative 72 divided by negative 9. A negative divided by a negative is going to cancel, so that's going to give me a positive answer. And 72 divides evenly by 9 8 times. And then 4 times negative 9. Here, multiplying a negative number. Here, I notice that Delta Math is doing an annoying thing. It's double signing. It shouldn't do that. It should have a bracket around the negative 9. But hey, no one's perfect. This is negative 36. Positive times a negative is a negative. 27 divided by negative 9 divides evenly, negative 3 times. A single negative, my answer is going to be negative. Two negatives, and they cancel. Here, this is negative 21, and so on, and so on, and so on. I've asked you to get a score of at least 5 today, just to get warmed up. Negative times a negative, well, that's a positive. Okay, cool. So this is multiplying and dividing integers that are positive and negative, just to get a bit of review and practice. Okay, and then you must push stop. There I go, and I push back. And it says, okay, I'm done that, so I can keep going. Simple operations here. Again, this is going to be plus, minus, add, and subtract. 2 times 0, oh, that's 0. 10 divided by 1, well, that's 10. Negative 10 to the 1 is just negative 10. Anything to the 1 is itself. 2 times 0? These are so easy. I should make you do 50 of them. No, I'm just kidding. So really, just getting a sense for this is so something divided by itself is always 1. So we got some real simple stuff here to just remind us, get ready. Okay, now here are some of the skills that we're looking at. These are the ones, these two, I think you do need to see what they're talking about. And I just want to get you some practice seeing the multiplication and the division of fractions. Sometimes this can be tricky to visualize or imagine. So here's how I do this one. Follow the instructions below to multiply the given fractions graphically. So we can use a kind of graphical representation of 1/2 multiplied by 1/3. So here I have 2 parts in my first fraction. So it's divided in half, so I need 2 parts. And only one of them is shaded like that. So the number of shaded ones will be on the numerator, and the number of parts are the denominator. This one, fraction number 2, has 3 parts, and one of them is shaded. So then I will say done. And now, correct. Now click and drag the second rectangle so that it perfectly overlaps the first rectangle. And now I can think of this in a few ways. This is 1/2 of a third, or it's a third of 1/2. Okay. So here is like I can imagine this because multiplication goes both directions. So this is either a half of a third or a third of a half. Both are true. How many little rectangles are in the overlapping region? Well, there's only one little rectangle in the overlapping region. So that's 1. And how many little rectangles are there altogether? 6. 1, 2, 3, 4, 5, 6. Okay. And then I say try both. Good. And so now I want to write this answer in an unsimplified form. So that'll be 1/6. So what I've discovered using this graphical method is that when I multiply a half by a third, I will get a sixth. Try that out. And it says, you are all done. Press submit to get credit. Yes, submit this. Hooray, it's correct. And I want you to get a lot of practice with that. The more you visualize these things, the more successful you will be. Fractions, such a key skill, especially going through the academic stream all the way till grade 12. Fractions are your friends. Please get comfortable with that. So you're going to want to do lots of that practice. Division, on the other hand, let's take a look at this situation. First, we have the division problem here as being represented is 3 1/3. Here is 1, 2, 3 on the number line. And then they added a third in the shaded region. And then they're going to divide that by 2/3. Basically, what this question is asking us is how many 2/3 are there in 3 1/3? And we see how it goes evenly. 1, 2, 3, 4, 5. So the answer type I need, I can just use a whole number here. It's just equal to 5. Submit answer. Yes. So that one is correct. So here, 3 and a third divide, and so then they will show us the answer. How many groups of y are in X? That's when we see a division question. And so reading this through helps me just like refine my thinking. So let's take a look. Next problem. We'll do one more example for you. Here's one that goes with a remainder. There's a remainder there. So this is 2 and a third, and I wanted to divide that by 2/3. I see there's 1, 2, 3 full 2/3 there, but then there's only a half of the next 2/3. So that would be 3 and 1/2. When I take 2 and a third and divide it by 2/3, I'll get 3.5. And I'm not doing any mental math here. I'm just seeing what the visualization is telling me. And it says, yeah, that's the right way to think of it. So you're going to get some practice with that. All right. Next, we're going to be converting scientific notation to standard form. Write this number, 6.5 times 10 to the negative 4 in standard form. As many of you discovered yesterday, when we have, or discovered a couple days ago, or already know, when we have negative exponents in our scientific notation, that means we're moving the decimal place to the left to make a very small number. So here, if I move the decimal place left, 1, 2, 3, 4, oh, maybe I'm having trouble visualizing this. So I want to also do my delta math with some paper nearby so that I can do things like write down the question. And then on my scratch paper, I'm going to go 6, 5, and I'm going to take the decimal place and go 1, 2, 3, 4. Okay, I need some zeros. 1, 2, 3. I'm going to put the decimal place there. I'm going to put an extra 0 for clarity. There's my answer. 0.00065. Note I read that as 0.00065. I don't read that as 0.00065 because 65 is the number that, like, when you're that old, you retire. It's not 0.65. So when it's past the decimal place, you read it just as its digits. 0.00065. Mid answer. Yes. Hooray, it is correct. And then this tells me, oh yeah, that's just a set of instructions. It says move the decimal point 4 places to the left. You can also work this out with your BEDMAS. You can do that, and it's correct. It'll be fine. But working with negative exponents will be challenging for you now until we get some more practice with that. Okay, so you're going to do that one. And then converting numbers to scientific notation. So let's write this one in scientific notation. I see that I would like to write this as 5.8 times 10 to the something. Why 5.8? Well, we always have scientific notation written with a single digit on the left-hand side of the decimal place. Always. That's standard for scientific notation. And I see that if I want to get the decimal place there, the decimal place started over here and moved over once, twice, 3 times, 4 times, 5 times. So I'm going to have a 5 here. So get some practice converting numbers to scientific notation. Yeah, 580,000 is big. And so we should write it as a times 10 to some positive exponent. Yeah, cool. Okay, and then multiply and divide in scientific notation. Aha. So this is something we started looking at yesterday. And I'll let you explore this and try it out today. Let's try it. 6.8 times 10 to the 4 and 9.3 times 10 to the 6. So what's the product is being asked of us here. The product means when I multiply two things together, what do I get? So let's find out. I'm going to copy down the question on a fresh sheet of paper and work it out. So there's a couple ways I can work this out. 6.8 times 10 to the 4 multiplied by 9.3 times 10 to the 6. One thing that I could do is expand each one of these numbers and then multiply them on my calculator and then feed the answer into Delta Math. And I think if you do that, you will find that math class is a little boring and it's kind of like calculator class. Okay. Another thing you can do is understand multiplication can be done in any order. I can multiply these 4 factors in any order I want. 6.8 is a factor, 10 to the 4 is a factor, 9.3 is a factor, and 10 to the 6 is a factor. So let's rewrite this as 6.8 times 9.3 times 10 to the 4 times 10 to the 6. And now let me ask the class. So let's get turned on our brains again. Can anyone do that in their head? 10 to the 4 times 10 to the 6? Well, maybe I'm not sure how to do that. So maybe what I can do is I can rewrite this as, well, 10 to the 4. That'd be 10 times 10 times 10 times 10. Okay. Then I'm going to multiply it by 10 to the 6. So 10 times 10 times 10 times 10. How many did I get? 1, 2, 3, 4. I need two more. Times 10 times 10. Okay. So there is my 10 to the 4 times 10 to the 6. Oh, I have an 11 there because I ran out of space on my page. There. So how many 10s did I multiply 10 by to get 10 to the 4 times 10 to the 6? So it's 10 times itself how many times? 10 times itself 10 times. Do I have another way that I can use exponential notation, that I can write that as a power? 10 times itself 10 times? Ten times itself 10 times. There we go. Just write it as a power. So 10 to the 4 times 10 to the 6 is 10 to the 10. As you do more of these, you may notice a pattern. I'll leave that with you. But then I still need to multiply that by 6.8 times 9.3. And, humans invented calculators for a reason, okay? 6.8 times 9.3 equals 63.24. So I have 63.24 times 10 to the 10. That's what this is. But I want to express that in scientific notation. I need to move the decimal place once that way. So I'd have 6.324 times 10 to the 11. Why? Because I moved the decimal place once that way. So I need to compensate for that over here. Let's put that in as my answer. 6.3, oops, go away, big keyboard. 6.324 times 10 to the 11. Submit answer. Yes. Hooray! And the math gods rejoice, and you give yourself a pat on the back for getting these questions right. So notice what they do. They do it a very similar way. They notice that multiplying two things, I can do that in any order. So they organized it in the same way. They put all their powers of 10 over there to get 10 to the 10. And then they did the 6.8 times 9.3 to get that. They moved the decimal place once. And then they said, but then I multiply by 10 and I haven't changed anything. Then they moved that over there as well. Okay? So their method is the same as mine. They're just even showing you more steps. So it's very helpful, this delta math. So you're going to get lots of practice with that. And then adding and subtracting in scientific notation, you just have to write it out. So if I have $5,900,000 and then I lose 5.3 times 10 to the 5, so 5.3 times 10 to the 5, so I need to move the decimal place over a few times. Let's do that. 5, 3, I've moved it once, twice, 3, 4, 5. So I'll have a 0, 0, 0, 0. Okay, so there it is. It's minus 5, 3, 0, 0, 0, 0. And I do the subtraction. So those zeros, just zeros. Okay, 0 minus 3, can't do that. So I need to borrow from there. And then that's 10. Okay, see, I can't take 3 away from 0. So I borrow one of these 9s. So that's now an 8, just I remember. And then 10 minus 3 is 7. These are all zeros, 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 zeros. 8 minus 3, 3. 5 minus nothing is 5. So if I give this in scientific notation, what I'm going to do is take this decimal place and move it once, twice, 3, 4, 5, 6 times. And so I will have over here 5.37 times 10 to the, what did I say? 1, 2, 3, 4, 5, 6. Okay, it's time 10 to the 6. Cool. Submit answer. Yes. Your answer is not correct.
Are you adding?
Oh, yeah, it says to add. Thank you very much. Thank you very much, Eva. I was subtracting. So, Delta Math gives me a second chance. Second chance. You don't always get the second chance, people. This is very exciting. So, I'm going to scratch that out. I am going to have this adds to 3. 9 plus 5 adds to 4, but I need to carry a 1. So, this is my number here, 6.43. 6.43. Good answer. I don't know how long it would have taken me to spot that, Eva. Thank you very much. So there. Now I got that one correct. And last two things. We are going to go back to using our factor practice from yesterday to do some greatest common factors. What is the greatest common factor of 39 and 48? 2. They're not both divisible by 2. Okay, so I can't use 2. Are they divisible by 3? Yes. 39 is divisible by 3 because 3 plus 9 is 12. Cool, it's divisible by 3. 4 plus 8 is also 12. So that's also divisible by 3. Do they share any other divisors? 6 won't work because this is not divisible by 2. In fact, this number, 39, is 3 times 13. I know that 48 is not divisible by 13. Because the next one would be 39 plus 13, be 52. Okay. You'll also notice 52 is not divisible by 3. Because I added another 13 to 39. So that would be 4 times 13, not 3 times 13. So 3 is my greatest common factor here. Submit answer. Yes. And then yes, that's correct. And then see, they write out all the factors, and then they figure it out that way. Our method of finding the prime factorization will also work. Bree? Yes, ma'am. And then finally, multiply and divide fractions. We visualized it before, but now we're going to do it. So this one might be some of the more challenging questions. I'll show you, I'll just go through the method, but I'm not going to talk about it too much because I want you to figure it out yourself if you've forgotten. 3 over 4 times 2 over 3 is equal to 3 times 2 over 4 times 3. But instead of doing that, I'm just going to go ahead and get my cancel pen out. Boom, boom, those cancel. And 2, that cancels. That's a 2. So this is 1 over 2. This is 1 over 2. Now you can use your area models to visualize these if you want, or you can use a method by hand if you want. Consider these kind of well, they are review, but they could also be a challenge problem for you today. Can you figure out how to do it? Okay, and that's our Delta Math for today. So thank you for showing up for your learning, everyone. Any questions, find me by email or hit me up in class.